If I'm going to explain this theory, the question is, are you going to understand it? Will you understand the theory? When I tell you first that the first time we really thoroughly explain it to our own physics students is when they're in the third year graduate physics, then you think the answer is going to be no. And that's correct. You will not understand. But this business about not understanding is a very serious one that we have between the scientists and an audience. And I want to work with you, because I want to tell you something. The students do not understand it either. And that's because the professor doesn't understand. Which is not a joke, but very interesting, I think. And I would like to explain it. My task, really, to explain all this, is to convince you not to turn away because it appears incomprehensible. That's what it takes 4 years of us to do to the student, is to get him so he doesn't run away because it looks crazy. The thing that's exciting about this is that nature is strange as it can be, in this sense, that the rules that are going to be obeyed, that I'm going to tell you about, by which this stuff is analyzed, by which we understand nature, the rules of the checkers, are so screwy, you can't believe them. Nevertheless, if you follow out the consequences and see what they do, sure enough, all the ordinary phenomena that happen, you can understand. That's hard to do, because you have to know how to count big numbers and do lots of arithmetic and so forth to see how it is that these rules really explain common experience. That will be more difficult for you to understand. What is not difficult is this. Well, that's difficult enough, yes, because it's so strange. But it's no more difficult for you than for the students, and no less difficult. I know sometimes I hear people coming to my lecture to say, oh, I'm going to come to your lecture, although I know I'm not going to understand anything. It makes me feel bad. Or when they come up afterwards, they say, oh, I enjoyed your lecture. It was lots of fun, but I didn't understand anything you said. I really am trying to make myself clear. So I would like to discuss this with you. Will you please keep coming in spite of the fact that you don't understand it? Because I don't understand it either. And the fun of it is that it's so mysterious. Okay? That's the fun of it. So this business about understanding requires just a few words. And so I'm going to say something about the relationship, and I hope we get some of your cooperation. Sometimes you don't understand because, say, the languages. The fellow comes from America and he talks too fast. That's my fault, and I apologize. I hope it's all right. That's a kind of trivial difficulty, relatively. Next kind of not understanding is because you perhaps use new words. That's an accident that comes because I'm working technically and I use the words every day, and I forget that everybody doesn't know what they mean, and I have to be very careful. Again, my job. And then there's a kind of saying that you don't understand it, meaning I don't believe it, it's too crazy, it's the kind of thing I'm not going to accept it. The other part, well, this kind, I hope you'll come along with me. You'll have to accept it. Because it's the way nature works. If you want to know the way nature works, we looked at it carefully, look at it, that's the way it looks. You don't like it? Go somewhere else. To another universe where the rules are simpler, philosophically more pleasing, more psychologically easy. I can't help it, okay? If I'm going to tell you honestly what the world looks like to human beings who have struggled as hard as they can to understand it, I can only tell you what it looks like, and I cannot make it any simpler. I'm not going to do this. I'm not going to simplify it, I'm not going to fake it. I'm not going to tell you it's something like a ball bearing on a spring. It isn't. So I'm going to tell you what it really is like, and if you don't like it, that's too bad, okay? There's also the possibility that you don't understand because you get a bit confused and you're sure that you must have misinterpreted what I said or something like that, and you get turned off, and that's, of course, a difficulty. Let me assure you that most of the time you did interpret correctly what I said, because if it does, it's going to be so shocking the way nature actually works that you're not going to believe that either. I faked it. I'm not telling you the full story, that for the students I have another way of explaining it, or something like that. It is not true. I'm going to be honest. Okay? So I'm going to ask you to try not to get turned off and not to be afraid. Relax and enjoy it. Realize that nobody understands it. Draw the experiment so you know what I'm talking about. It's hard to make a water surface that's vertical. Yes, so we'll make the water surface horizontal. And light's coming down, and some of it's reflected, and we put a counter here to see one of those photo multiplier things, and we count the count. And we know how much we should have got, and we find what. How can it be partly reflected? I forgot to say when I was talking about the particles, when you have light of a definite color, the energy that the first one knocks out is always the same. Each particle is the same strength. There's not half particles. It's a full photon. What you get is full photon. But if the light is dimmer, what does that mean? There are fewer of them, right? Simple. So, of 100 that come down here, perhaps 4 out this way and 96 go through. What determines which 4? How does it, which one that's coming down of the 100 knows what to come back up? All right? So the situation is that the phenomena is probabilistic. It takes odds. It comes down here and has a 4% chance. 1 out of 25 trials. Huh? I think you know what odds are. If you have, for instance, a die, and you want to get a 1 and you roll it, well, it doesn't come out so often, but it comes out sometimes, 1 out of 6. And what that means, if you roll die 100 times, let's make it 600 times, a little easy. If you roll a die 600 times, you might get 105 ones, or maybe 92 ones, or something like that, right? You get about 100. And if the numbers were bigger, the accuracy in percentage is bigger, not accurate. So if you have 6 billion, no, not 6, because I got 125, 25 billion of these coming down, about 1 billion will come off. Okay? Now, let's see if the next feature is how can it be probabilistic? Suppose that I had a light so weak that I had only 1 photon coming every few minutes. Will this counter go off, or will the one down here go off? 1 out of 25 times this one goes off. Which time? What determines that? Possible theories. Nothing. Pure chance. The world is made of chance. That would mean that the physicists can't predict the future. It would mean that if you set up an experiment with exact conditions, you cannot predict what happens in the future, because you can't predict whether it's going to go up or going to go down. You just got 4% odds. Your whole beautiful structure of science is reduced to computing odds. Nature, instead of being definite, does everything by chance. Not so good. Other possibilities are little spots on here. And the photon has to hit a spot on the surface. And Newton had several things. You'll find out later when I give you more phenomena, how these various explanations, which way it's going to go, and why the spot one doesn't work. But I'll give an argument that Newton made about that. He said it can't be that, because, he said, you can polish glass. It's wonderful. I love to read these old guys. You know, they knew you could polish glass, but they had the intelligence to deduce from the fact that you can polish glass that there's no spots on it. Like, why? What's polishing? See, he polished it. He carved his own lenses. He ground his own lenses, so he knew what it was doing. He takes a coarse-grained, sand-like stuff, what do they call it, the polishing powder, the grinding powder, and that shapes it. But it cuts fairly obvious grooves. And you take a finer one with finer particles, and you cut the grooves of finer, and you make the grooves finer and finer and finer. And after they're fine enough, suddenly it's smooth, and the light comes right through. When it's coarse, it's bounced around. And so he concluded that light cannot see the grooves, that when I polish it, it's not that it's smooth, it's still bumpy, but on a small scale, whereas when I have the big grains, it's on a big scale. It can't be any different. When I polish with the small grains, it's just a small scale of regularity. But somehow light doesn't see anything on a small scale. Correct. All experiments have shown that this is absolutely not the right explanation. If it was, there'd be all kinds of ways of testing that. I told you we can measure down to 10 to the minus 15 centimeters and so forth. And that what would happen would be you'd be able to find some area to focus very carefully the light so that the reflection coefficient would be higher than 1 in 25 because you happen to be near a place where there was a spot. You can't do it. No matter what you do, it's 1 in 25. Other possibility, the light that's coming down here, the photons are doing, like footballs. And they spin. And depending upon whether they hit with the nose point or with the flat point, depends on whether they bounce back. In other words, something inside the photon is determining which way it goes. Again, no. Because if that were the case, the light that went through would be all of a certain kind of football. And if you try the reflection again, you'd expect a different number than 4% because of the fact that they're all lined up, and you can't line light up. You can't fiddle around up here by any kind of filtering that'll change that percentage. All the lights, photons, are identical if they're the same color, one color. They're all identical, and they behave with 4%. Are we therefore reduced to this horror that physics has got reduced not to these wonderful predictions, but to probabilities? Yes, we have. That's the situation today. In spite of the fact that philosophers have said it is a necessary requirement for science that setting up an experiment exactly similar will produce results exactly the same the second time. Not at all. 1 out of 25, it goes up, and sometimes it goes down. Unpredictable, completely by chance. All right, I already see you turning off. I can see you say you don't understand me. You can't understand that it could be chance. I don't like it. Tough. I don't like it either, but that's the way it is, okay? I don't understand it either. I don't understand it. It must be that nature knows whether it's going to go up or down. No, it does not be that nature knows. We are not to tell nature what she's got to be. That's what we found out. Every time we take a guess as how she's got to be and go and measure, she's clever. She's always got better imagination than we have, and she finds a cleverer way to do it than we have thought of. And in this particular case, the clever way to do it is by probability, by odds. And so the first aspect I have to tell you about then is that light works by probability. All right?
Do you like the idea that our picture of the world has to be based on a calculation which involves probability?
Not really, if I get right down to it. I don't say I like it, I don't say I don't like it. I am very highly trained over the years to be a scientist, and it's a certain way I have to look at things. When I give a talk, I simplify a little bit, I cheat a little bit to make it sound like I don't like it. What I mean is it's peculiar. But I never think this is what I like, this is what I don't like. I think this is what it is, and this is what it isn't, okay? And whether I like it or I don't like it is really irrelevant. And believe it or not, I have extracted it out of my mind. I do not even ask myself whether I like it or I don't like it, because it's a complete irrelevancy. It's a kind of a dumb answer, but it's true. And when I'm lecturing, I shouldn't have said I don't like it. What I was trying to say is you probably don't like it. There's nothing I think we can do about it. It might have been something else. I don't know how else to express it. It's not really personally a dislike.